So this right here is a Centipede PCB, and it's an unhappy Centipede PCB. I got it with my Centipede cabinet. It was a freebie spare, but obviously it's not working. And my working one's right here. So the idea is to get this thing working so I can have a good spare. And also it might be kind of a fun project just to figure out what the heck is wrong with it. So I already started this video once, before I went to bed. And I was up for 23 hours, so I was just kind of out of it. But I did try all the good ROMs there and there, and then I swapped the RAM around, and that didn't really do anything. So we're in for something more fun, I guess. So I'll pop it in the cabinet, and we'll see what it does. If you're watching something on my channel, I'm going to make the assumption that you know what a centipede looks like. And unfortunately, this is kind of wrong. We got some shit and vertical strips, and we got whatever the hell that is. We got the centipede flashing red and green. I think he's trying to flash between, heads and just body parts. You got the shooter shooting himself here. It's not on free play. It's missing the dip switches for the coin setting, so I can't even, put it on free play, so I'll just put a coin. Alright, so if we start it, you can only go left. You can shoot copies of yourself. Good strategy. Alright. Maybe I'll put like some jumpers on the dip switch. Maybe that'll make some of this shit go away. Maybe not. Probably not. But I think it's 2 coins a play or something like that. So let's put it in test mode and see what it does. Centipede is supposed to be pretty good about giving you a test mode that will tell you what's wrong with this RAM. But this is not a typical behavior, that's for sure. It's supposed to have up to 10 beeps, so that's unusual. So of course I already checked the ROMs, and then I swapped the RAM around, and there was no change in the behavior. So we got the VRAM we can swap around, since I have no real way to test that. So I might socket all these and then swap them around and see if the behavior changes. But if you notice, all the garbage is happening, or at least all the weird garbage is happening on the top side of the screen, which is the left side. So I wonder if I'll be able to figure out which memory is addressed on the second half of the horizontal. I don't know if it like switches in the middle of a scan line. I don't know. I'm not sure how that works, or maybe I'll have to look at it. I don't think it would switch which RAM is being accessed during a scan line. It'd probably happen during horizontal blank, so it probably it accesses these two for one line, next line, next line, next line, and then just kind of goes down through there, or in some variation of that or something. I don't know. I'll look at it. Also, in order to test it on my bench here without having to put it in the cabinet and kneel down and poke around, I wired this up. I was going to make some sort of weird test bench setup thing, so I got a piece of wood and screwed some useful components on it, but I'm going to make some sort of adapter deal. But for now, I just soldered shit onto here, and in order to get video to work, Centipede does composite output, black and white only. So I got this video cable going up to this composite monitor, and solder this to the ground. And then since Centipede is weird and outputs 3 volts peak to peak on the video, you gotta stick a resistor in line to make a voltage divider, to make it so it's less than a volt, to make the TV happy, because I don't want to blow out my nice TV trying to hook up this piece of junk. So to reiterate, I've already tried a different pokey, or actually I put this pokey in the other board, so that works. The CPU works, the ROMs are good, the video ROMs are good. I swapped the RAM, the behavior didn't change, so I'm assuming the RAM is good. And so, just looking at the garbage on the screen, you can see that the garbage is only on one side. I'm going to ignore the motion objects problem here for now. I want to see if I can figure out what the garbage on the screen, right side of the screen, is for. And you can see it's just, you know, one half the screen. So the game counts, you know, pixels across as it's running to determine where it's at and what it needs to draw at any given moment. So we got some problem when it accesses the right side of the screen. So of course it's counted in binary. So we got, you know, pixel 1, 2, 4, 8, 16, 32, 64, and then 128. So when 128 is turned on and it's counted through the rest again, we got some problems accessing either the memory or whatever. So, and it only happens every other line, it seems. The garbage is only on every other line. Nice. And then this line seems to be some signals floating or something like that. So the graphics are kind of spazzing out. So everything on every other line looks to be valid. See, COINS, you know, one. So 2 coins, 1 play. So you can sort of see that it's working on every other line there. So I was looking at it and pull up the schematics or whatever, trying to figure out, instead of being a normal person and just changing the RAM out or something like that, I'm just going to try and figure out what is being accessed at that given moment, and then just swapping stuff around to see if I can make the behavior change. So this circuitry right here changes whether the CPU or the video generator has access to the memory, depending on where in the scan line it is. Because if it's in horizontal blanking, I think you can it's accessed by the CPU or MPU as it calls it, or something like that. Then from here, the data is output to this right here, which is the playfield multiplexer. So this decides whether the CPU can read from the memory or the video generator over here is reading from the memory. And so we need to look for what when 128H is enabled, because that's when the garbage starts. So this thing outputs like 32 bits of data at a time, and since all this stuff can only read 8 bits at a time, it has to be multiplexed, and this basically chooses what data is being issued out at any given moment, and that's controlled by this guy, which is controlled by, you know, the timing from the video, where the pixel is. And you can see that this one has the potential to turn on based on 128H. So this can determine which side of the screen's on, and we know that's kind of working, or that's working, because it is switching the video and it's displaying half the lines correctly, as you can see by our 2 coins, or 2 CO, or 2 CIS, you know, 1 play, whatever the heck. So every other line after that's just kind of corrupted. So I need to figure out what is being accessed during those lines that's getting stuck on, and then if I can figure that out, I'll know exactly what the problem is. Maybe, hopefully. So I'm trying to logic this out instead of, you know, poking around aimlessly. At least that's the idea. So I hereby interrupt this bumbling video to bring you a paper presentation on how I understand Centipede's video hardware to work. So I guess it's similar to the Nintendo Entertainment System, how it has tiles that build the screen. And since the screen is, you know, sideways, it's a little bit funny to think about. But if we look at the screen as if it's like a regular TV, the video is 256 pixels wide, and each tile on the screen is 8 by 8, so it can fit 32 tiles across the entire screen. And so I guess I'll step through how this thing works. So I'm going to assume that you know what binary is and how it works. So the game hardware will keep track of where the beam is on the screen at all times. So it has two different lines that it will count. So it has the horizontal position and it has the vertical position up here. And as the game scans the screen, these will come on and off. And what this is right here is the addressing for the memory. I'm not going to go into how the CPU puts data into the memory, since I don't even know how that works yet. So the addressing goes off of where the pixel is on the screen. So say we're trying to draw the first dot on the screen. So we're at horizontal position 1, vertical position 1, or whatever the heck. So this will see that, and it will like use these use the information from where the pixel is to tell the RAM what to display. But the RAM altogether will output 32 bits, which is 4 bytes, and that's too much for the rest of the hardware to understand all at a single time. So we have this is a multiplexer, and that will select between any of these bytes here, depending on other circumstances, such as which line it's on, if it's on an even or an odd line, or if it has made it past the half of the screen, which is at 128H, which is right here. So this is the screen, or a representation of it. So I guess we'll then it goes to a latch here. So the data that it picks goes to a latch, and then it goes out to the video hardware for it to be displayed for 8 pixels, because this latch will hold the data for 8 pixels. Because what this does is similar to a Nintendo. 1 byte represents 1 character, and the game only has so many characters in ROM that it can pick from. So every byte is assigned to a different character or an object that goes on the screen, and it'll latch it, and the video hardware will read that and draw it for 8 pixels. Then after that 8 pixels, horizontal, or 8H, will become a 1, which will change what the memory is outputting. And we're still not we're not to the halfway point, and we're not on the next line or next 8 lines yet. So we just drew the first 8 pixels there. So then we're at line 1 here, or we're at horizontal position 9 now. It changed the memory on byte 1, and it's going into the multiplexer and out the video again, and it does that. So it keeps on doing that over and over and over. This will change what the memory is outputting until we get to the midway point, where everything goes back to 0 again, and it outputs the same thing. So from here to here, we've been just reading byte 1, but now we reset this back to 0, 0, 0, since we're at 128 here. This will start going through the same memory addresses again and outputting the same things on the bytes, but instead of picking byte 1, since 128 is now activated, it's going to pick byte 2, and it'll start drawing on through to the end of the screen here to 32. So then what happens after that is it just keeps on doing that over and over and over again until we make it to vertical line 8 here. So we're going to start on vertical line 8, which is the next row of blocks on the screen. And so what it does is that it just starts all over again. So we haven't made it to line 16, so none of this has even come into the equation yet. This is 0, so it's going to try and put out the same data onto the 4 bytes here as it would right here. But the difference is that now we're on line 8, so it's going to pick a different byte. It's going to pick byte 3 now, and it'll go out to the video. And it'll keep on doing that over and over and over again until we get to line 120, or the horizontal position 128 again. And then, of course, we'll meet the requirements for that, and it's going to switch the multiplexer out again, start reading off of byte 4. So after these two rows of objects have been completed, it will tick this one right here, and it will start serving different data for the next 2 rows of blocks. and then it'll tick this one right here, and then it'll serve the next two differently. So as you can see by the corruption of my video, this right here is messed up, this is messed up, this is messed up, this is messed up, this is messed up, and it's every other line. So this is good, this is messed up, this is messed up. We have those weird vertical lines. So how I came to understand what my problem was is that, say, bytes 1 and 2 are for here and here, and then byte 3 was for this side of the screen right here. So whatever is serving up byte 4 right here is all goofed up. But which one is it? Because these are all involved in this big mess here. So I guess the next question is, how do I know exactly which chip on the RAM is bad? Well, I guess if you look at it closely enough and follow these lines, you'll start to notice that each pair of RAM chips makes a byte. So this is byte 1, byte 2, byte 3, and byte 4. And the multiplexer switches between those 4 pairs of RAM chips. So how do I know what goes where? I don't know. So you got 4 bits coming from one, 4 bits coming from the other to make 1 byte. And so you'll see on the Centipede test screen, it will list all the characters it can display and in order. So I noticed that all my garbage tiles were the letter P. And if you count from 0, 0, which is that blank spot, and then count up to where the P is, P actually lands on 16. What does that sound like? So I guess with our binary number here, of course we have our 0, 1, the 2, the 4, the 8, 16, I guess 32, 64. That's what those numbers represent on the byte. So maybe our 16-bit is stuck. How do you know which one that is? Whichever one's connected to the 5th bit, or I guess you could call it the 4th bit, because in binary things start with 0. So there's our 4th bit. So whatever is outputting to that on the right hand side of the screen is bad. And if you look up the data sheet and do all this hoopla trying to figure out what's selected at any given time, you'll notice that PFD here, or whatever, 28 would have been selected, and it comes from this chip. So there you go. Well, I found the issue. It's definitely a bad RAM chip. Here in the image I have my scope and the monitor up, and so how I actually figured out, I was right, that was the exact freaking pin that was freaking out. So if I mash the reset button now, if I can get it into a state where it's supposed to have a blank screen like that, and you can see that the corruption is still there. If I probe that pin, that's what is it? The 16, the bit 3 or whatever the hell for the output there. If I probe it, you can see that it's the one that's still active, and it's doing all sorts of weird stuff. Well, I got it triggering. I shouldn't trigger it. That way you can actually see it start like floating and stuff. Like, look at this. It's just freaking out for no reason. It shouldn't be outputting anything right now. And it's like going from floating to high and all sorts of weird stuff. So this RAM chip, whatever feeds this, is our problem. Which one is that one? That is PFD28. That comes from N5. So N5. N5 is that one. I wonder what happens if I just like hold that line low. I mean, it's already dead, and what can possibly go wrong? Where's my meter at? I'll just stick it in current mode. I'll just stick it in current and then frickin' hold that line low and see what happens. I'll probably just make those lines disappear. So what pin is that? I can just do it from this guy right here. It kind of makes it go away, but let's see, we got some other junk. I don't know what the 0 is. I really should just take a picture of this instead of cycling the power on my poor Centipede a million times. So if P was bit 3, that's 16, so that's 32, that's the next bit up. So whatever bit's next to 3, which is 4, bit 4. What is bit 4? Bit 4. So there's a... Wait a minute. No, that's bit 5. That's bit 4. Bit 4 is that. Bit 5. Huh? 1, 2, 4, 8, 16, 32. That 29 comes off the same RAM. So yeah, the zeros are coming from the same RAM. If I held both of those down, then it wouldn't display the zeros or the P's. So that's definitely our problem. So for shits and giggles, I'm going to swap this around with what would make it. Let's see what would make it. So you see, we have the junk being drawn on the 2nd line, 4th line, 6th line stuff. What would I do to make it shift up 1? Which RAM would I replace it with, since these are all the same? And that's controlled by this guy here, and so if blah 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 blah. Let me think about this. All right, so I mapped this out a little bit so I can more easily understand what the hell is going on. So on the left side of the, or the right side of the screen, every odd line is going to be controlled by L7 and L5, or memorized by L7 and L5. So it'd be these two, and then N5 and N7 are sort of even, so it'd be these two. So these 4 are going to be for the right side of the screen. These 4 are going to be for the left side of the screen. So what I'm going to try and do is I'm going to move my garbage from the right side to the left side on the same field. So I'll move my beloved N5 here, move it to M5, I think. No. Yeah, M5. I'll move it to M5, and I should get the same P's and stuff because it's on the same side of the bus, or whatever the hell. So it'll always stick the same bits in a different spot. All right, so I kind of marked that. You can barely see it, but I marked it with a marker, so I know which one's bad still. I swapped those around. I thought I was gonna socket it, but I didn't have the right sockets. So by the time I figured that out, the chips were already out. So I'm like, ah, screw it, just throw it in anyway. Whatever. Let's see what happens. Oh, look at that. I moved the problem to the other side. And yet it appears that that memory has to do also with motion objects, which I was kind of wondering, because now the Centipede's doing something slightly different and the shooter's kind of spazzing out. But I can read the high scores now, so that's kind of cool. So we moved it to the exact opposite. Oh, look at that. The Centipede's getting stuck up on the P's. There's too much P. At least the 600 point thing isn't getting stuck all over the place anymore, but oh, look at that. Those zeros are just kind of walking around. That's kind of cool. Alright, so I wonder, actually, so I'm going to see if the test mode still has a beepo freak-outo, but I don't have a speaker hooked up to this, so I'm going to figure out a way to switch test mode on. I wonder if there's a jumper for test mode. There might be. That'd be nice. I'll get my oscilloscope. I'll grab the analog one to see if any sound's coming out. Alright, I got this to look at the audio in close to real time, I guess. So that's hooked up to the audio too, and then I got my meter hooked up to ground in current mode so I can ground things out and make things angry. So if I point the camera at the scope here and I hit the slam switch, the game starts screeching at you because you're slamming the cabinet. Stop slamming the cabinet. Operator, please help. They're beating up on me. So, of course, this thing doesn't have a dedicated test point for the test mode, because why would it? So it's going to be that one. No? 13. Oh, that's coin. I've put coins. Or one coin. Was I touching L9? Or K9? 11. It's still passed. Now if I go... It kind of desyncs from my TV. And it's still doing that. Is it watchdogging when it does that? I don't know what I just missed because I was pushing the wrong buttons, but I came to the conclusion that this is really stupid. So if I go to the reset pin on the CPU, was it poking the pokey? I don't know. So that's the reset pin. You go over to K9 to turn on test mode. It's watchdogging. It's watchdogging only in test mode, so it can't even finish its error beat count. So that's cool. That's very useful, Atari. I can't tell what's wrong because your game is just resetting itself. And so a few days later, I got some goodies in the mail. I got more dip switch blocks, so I can put one right here, so that can be selected. And I got RAM, so I replaced the bad RAM. And I also gave the PCB a bath with dish soap in the sink with tap water because we're high quality here. Turned out pretty nice and clean. Clean enough for a spare Centipede board, so I got it hooked up. Let's see if the errors go away, the problems go away. Wow. There's still a problem, it looks like. I'm not sure why the dude's shooting himself still, and the Centipede shouldn't be giving 600 points, but that's a step in the right direction, so there's no more issues with the RAM on the screen. Let me throw it in the cabinet and see what the results are like. Alright, time to see what this thing does. Well, we already got a glimpse at what it does. Hey, it passes the self-test. I forgot I even had that on there. Or it doesn't pass. So it's shooting its own dudes. I didn't hear any audio. Alright, so there's no audio. Probably because there's no errors with the RAM. The controls are not quite working yet. I can only go left, but I can still go up and down, so at least there's that now. That's an improvement. Every time we shoot something, we get like buku points. So at least now, I can set it into test mode, and it has a valid test mode. It looks like it's actually running and all that good stuff. So let's stick it in a good color scheme to run. So FF, I think that one should be the code for the EA ROM, which is the one that stores the high scores. And I don't have that chip in there right now since I've been power cycling it a lot. I kept the chip out, but that 4 next to it should indicate a ROM failure. All right, so never mind. I looked it up, and 4FF. The 4 means that the EEROM is failed, or EA ROM. I call it the EEROM. And the FF means that it has been deleted. So we still have something wrong with the controls. We still have something wrong with the player or the motion objects, but at least it will run the self-test now. So we got to figure out why it's shooting dudes and why it is only controlling to the right. However, I think this will be good for one video, and I'll make a part 2 with the more stuff when I get to that.